the coefficients of the number that you're going to be dividing. So my coefficient on the first one is a 2. So I'm just going to write a 2 once this starts writing. There we go, 2. My coefficient on the linear term would be a 1. So I'm going to leave a space and put a 1. My coefficient on my constant term is negative 10. Okay. So again, the beauty of synthetic division is I don't have to worry about the variables. I just worry about numbers. So I'm not going to make mistakes there. Then what we're going to do is we're going to put a little half box in front of that. And the number that goes into the half box is the 0, or the number that makes this 0. Remember when we were talking about domain and range? If this is in my denominator, what value of m can it not equal to get a 0 in the denominator? 2, right? Does everybody see that? Because 2 minus 2 would be 0. So when I say you're 0, I'm just looking for the number that makes this expression 0. So because the 0 here would be a positive 2, I'm going to put a positive 2 inside that half box. I guess I should have shifted over a little bit. If this was m plus 2, then we would go in the half box. A negative 2. If this was m minus 3, then I would put in 3. If it was m plus 1, then I would put in negative 1. So this number right here is the 0, and to find your 0, you just take whatever your divisor is, equal it to 0, and then solve it, right? Okay, so now this is the process for synthetic division. I'll go through it very slowly. I'm going to put a line, give yourself a little bit of a gap here, because we're going to be inputting numbers right here. Your first step for synthetic division, you always, always, always bring down that first term, which happens to be your leading coefficient of your polynomial in the numerator. Okay. Then we're going to multiply the number in my half box by that number. So I'm going to do 2 times 2, which is 4, and I'm going to place that 4 below the 1. Okay. So this was step 1. Step 2 was multiplying, and then that number goes there. I'm just putting arrows here maybe to help you see what's going on. Okay, so then the next thing we do, instead of subtracting like we do in long division, you add these numbers together. So 1 plus 4 gets us 5. I'm going to put 5 below. Now I'm going to do the same thing like I did here, but with the 5. So now I'm going to do 2 times 5, which is 10. I'm going to put that up there. And now I'm going to add, which gets me 0. Okay. Now when we did our long division, every time we divided a polynomial by another polynomial, my solution was always 1 less degree. Not quite sure if you noticed that or not. So if we started with a cubic and I divided out a linear monomial, then it took it down to a quadratic. If I started with a quadratic and I divided by a linear binomial, then it went to a linear. So it always goes 1 less degree, because when you're dividing, you subtract, right? So here I started out with a quadratic. So that means my solution is going to be 1 less, which would be an exponent of 1. So I'm going to put an m behind my 2. This is going to get no m, because 1 and then 0. And then the number at the end, this represents your remainder. So my final solution is going to be 2m plus 5, because it's a positive 5. Okay. If we wanted to remember how to do that using long division, you don't have to put this in your notes. I'll just do it really quickly. If I did it long division, I would have m minus 2, 2m squared plus m minus 10. M times what gets us to 2m squared, 2m. Notice it's 1 less. So that gets me 2m squared minus 4m. Subtracting gets me 5m minus 10, which would get me a plus 5 up there. 5m minus 10. Subtracting gets me to 0. So don't I get the same answer? 2m plus 5, 2m plus 5. Yeah. What's a little bit easier? I think synthetic division. The only thing about synthetic division, it only works with linear binomials. If I had to divide by a quadratic binomial, then I wouldn't be able to use synthetic division. Okay, so that's the only downfall of it. But I'm only going to give you problems that have a linear binomial as the divisor. All right, let's try it again. So we've got 3x to the third minus 2x plus 5, and we're dividing by x minus 3. So again, I'm dividing by a linear binomial, so I can use synthetic division. What number is going to go into your half box? 3. Good. So 3 goes in the half box. Now let's focus on our coefficients. My highest term is cubic, so the coefficient on my cubic is 3. Now let's go to quadratic. What would be the coefficient on the quadratic term? 0, because it's not there. You need to make sure you have every single term represented. What's the coefficient on my linear term? -2, right? Linear, cubic, quadratic, linear, and then my constant is 5. There are my numbers. Okay, give yourself a big addition bar down there at the bottom. Your first step is always to bring down your leading coefficient, which is a 3. Now let's do some multiplying and adding. So 3 times 3 is 9. 0 plus 9 is 9. 3 times 9 is 27. -2 plus 27 is 25. 3 times 25 is 75. 75 plus 5 is 80. So I do end up with a remainder here. So that means I'm going to have a fraction in my answer, and that's okay. We started with a cubic, so that means my quotient is going to end up being a quadratic, so it would be 3x squared. And I'm going to have a plus 9 what? X, good. Plus a 25, and then plus 80 over, we divide it by x minus 3. Okay, again, synthetic division only works when your divisor is a linear binomial. But when it is, it makes it kind of nice. Because all you're doing is just multiplying and adding, and you're not worrying about the actual variables themselves and their exponents. Right?
Synthetic division is better.
Yeah. I like synthetic division better too. All right, so if you were to see something like this of dividing functions, so if you saw f of x is equal to 2x squared plus x minus 10, and we had function g of x is equal to x minus 2, and we put our polynomials into function notation, we're just going to do the same thing, except dividing and then talking about the domain. Okay, so if I wanted to find f divided g of x, what do you think I'm going to do with these two things? Just divide them, right? So f divide g of x is the same as just doing 2x squared plus x minus 10 divided by x minus 2. So now we got two methods. Do you want to do synthetic division? Do you want to do long division? Synthetic? Can I do synthetic? Yep, because my divisor is a linear binomial. All right, so let's go ahead and do that as a sidebar. So 2 is going to go in my half box. My highest term is quadratic, so the coefficient there is 2. So quadratic linear, my coefficient of my linear term is 1, and then my constant is -10. The only thing about synthetic division is if you are missing a term, if you forget to put in that 0, you're not going to notice that you missed it. In long division, yeah?
This is the same equation as the one of the first examples.
Oh, well, that's okay. Then we know what we're getting, right? If you forget the 0 in synthetic division, you won't notice that you missed it. In long division, if we forgot it, when you start multiplying through and lining it up underneath, you would notice, oh, I have an x squared here, but right now it says an x, so I probably missed something. Okay? So you need to be really aware of if there's a gap. So what was this one? So 2, 4, 5, 10, 0. So my solution was what? 2x squared plus 5? Or 2x plus 5? Why did I say x squared? I don't know. So 2x plus 5. Now we have to talk about the domain of the quotient function. My resulting polynomial no longer has a divisor, but there is a number that we originally can't have in the domain. What value makes my denominator undefined? 2, right? So then we need to say, so for my final answer, I'm going to say f divided by g of x is equal to 2x plus 5, but then I'm going to put a comma, and I'm going to say x cannot equal 2. And the only time you have to do this is if we're talking about functions. So if your polynomials are just polynomials, you don't have to worry about stating what the domain cannot be. Only when you're talking about functions and dividing functions. If you multiply functions, there is no restrictions on the domain. It's only when you're dividing is when there would be a restriction there. Okay, so this would be your final answer for that part. If I wanted to evaluate it for -3, what would our solution be? So it'd be 2 times -3, so -6 plus 5, so -1. So f divide g of f, or of x, of -3 would be equal to -1. Yeah? All right, let's do some practice. So grab yourself either scratch paper or a practice sleeve, and let's make sure we've got all these methods down for division.